Welcome back. Today we're going to be looking at linear functions, and we're going to start looking at the specific types of equations that we're going to see in this unit. And so today we're looking at the slope-intercept form. So in the last couple of days we've been looking at the slope formula, we've been looking at what slope is, and now we're going to start looking at how it relates to graphs and functions. So first of all, the slope-intercept form, this is the equation of the line. So y equals mx plus b is the slope-intercept form of a line, and it has special features. So y equals mx plus b, we've got two important parts in this equation. M is our slope, and b is our y-intercept. And those are the most important pieces to remember with this formula. If it's written as y equals mx plus b, we know our slope, we know our y-intercept, and tomorrow we'll actually use those to graph functions. So first of all, what is a slope-intercept form, and what is a y-intercept? All right, so if I draw a line here, the part that goes through the y-axis, this would be 0, y, that's called our y-intercept. So when we cross the y-axis, that's called our y-intercept. So it's where the line lies on the axis. And in our formula, y equals mx plus b, the b value is going to be that y-intercept. And the m, again, is going to be our slope. Now, when we're looking at a y-intercept, it will always be 0, some number, okay? And that would be our y value. Later on in the unit, we're going to be doing questions where you're told that the x-intercept is something and the y-intercept is something, and you have to find the equation of the line. It's really important that you remember y-intercept means that x is 0. And if we were looking at an x-intercept, y is 0. So we're going to look at a couple equations down here. First one says y equals 2x minus 5. And we're being asked for the slope and the y-intercept. Again, y equals mx plus b. M is our slope. B is our y-intercept. So for this question here, 2 is our slope. So m equals 2. And b, the sign in front is important. B is negative 3. So if we're actually b would be negative 5. I think I went 2 minus 5 in my head. So b would be negative 5, and that would mean my y-intercept would be 0, negative 5. All right, looking at the next example, we've got y equals negative 1/2 x plus 3. My slope would be negative 1/2. Again, that sign is important. There's a difference between a positive slope and a negative slope, as we looked at before. And our b would be a positive 3, meaning our y-intercept is going to be 0, 3. All right, so sometimes when it comes to using the slope-intercept form, y equals mx plus b, the equation isn't set up for us automatically. Sometimes we have to do a little bit of manipulating first. So here I have 5x plus 2y equals 10. If I want to put it in the form y equals mx plus b, I need to rearrange my equation to get y by itself. So this is why we started off the unit by practicing solving equations. Ultimately, I need y by itself. So if you remember, when we're rearranging equations or solving equations, we're doing bed mass backwards. So that means I need to move the 5x first and then the 2. So I'm going to subtract 5x from both sides. That's going to give me 2y equals negative 5x plus 10. Then I'm going to divide by 2 on both sides. And that leaves me with y equals negative 5 over 2x plus 5. Once my equation is written in slope-intercept form, then I can identify my m and my b and my slope and y-intercept. So m would be negative 5 over 2. Try to keep it as a fraction in lowest terms. My b is 5, meaning my y-intercept is 0, 5. Number 2, I want to get y by itself. In this case, I already have everything on one side of the equation. I want y by itself, so it probably makes sense to subtract the 2y. Now, that being said, I often like to keep my y positive because in the end I need it to be positive. So I'm actually going to move the 3x and the 6. So minus 3x and positive 6. I'll show you the other way to do it in a minute. So we have 2y equals negative 3x plus 6, divide by 2, divide by 2, divide by 2. Y equals negative 3 over 2x plus 3. Now again, the other way that you could have done it, we have 3x plus 2y minus 6 equals 0. You could say, well, the easier thing to do is just move the 2y, which you can do. So 3x minus 6 equals negative 2y. And then you have to remember to divide by a negative 2. And so we end up with negative 3 over 2x plus 3 equals y, which can be rewritten as y equals negative 3 over 2x plus 3. So our slope would be negative 3 over 2, and our y-intercept would be 0, 3. Both methods work. One of the reasons that I tend to stay with the first method is because I'm a person who often forgets to divide by my negatives. I miss those negatives a lot, and so I try to always rearrange my equation so that my y stays positive. All right, we talked about this the other day, that we can have both parallel or perpendicular lines or neither. So now that we've worked with the equation, we can identify whether these equations are parallel, perpendicular, or neither. So if we look at the first equation, y equals 2x plus 5, the slope of my first line is 2. The slope of my second line is 2. And since they're the same slope, that means that my lines are parallel. If I look at my next example, I've got y equals 1/2 x minus 4. So my slope of the first one is 1/2. The next one is 2x plus 7, so my slope is 2. In order to be parallel, the slopes have to be the same. These aren't the same, so they're not parallel. And in order to be perpendicular, they have to be negative reciprocals of each other. Well, the negative reciprocal of 1/2 is negative 2 over 1. This is not negative 2 over 1, so these are neither. And the last question here. It says, write the equation of the line with a slope 3/5 and a y-intercept of 6. So my slope would be 3 over 5. My y-intercept is 0, 6, meaning that my b value is 6. And my equation is y equals mx plus b. So y equals 3/5 x plus 6. All right, so tomorrow or in the next lesson, we're actually going to start looking at graphing equations. We're going to practice one here, but we're going to get into more detail with it tomorrow. So the question says, change forms from y equals mx plus b, and then graph the line. So we have 3x minus 2y equals 6. So this is sort of just a heads up to what's coming. We've got 3x minus 2y equals 6. The first thing I'm going to do is try to get my y's by themselves. In this case, I'm going to move my 3x. Again, there's more than one way to solve these. Negative 2y equals negative 3x plus 6. I'm going to remember to divide by a negative 2. And that leaves me with y equals positive 3 over 2, x minus 3. So using that information, I know that my slope is 3 over 2. I know that my y-intercept is negative 3. So my y-intercept is negative 3. My slope is 3 over 2. So my starting point would be my y-intercept, and that's going to be 0, negative 3. So I'm going to plot that point 0, negative 3. And I have a slope of 3 over 2. Well, 3 over 2, positive 3 over positive 2, would mean up 3 and right 2. Or it could also be the same as negative 3 over negative 2, because that also gives me a positive, which would be down 3, left 2. So from that point 0, negative 3, I can count up 3, 1, 2, 3, right 2. Try not to say over 2, because that doesn't give us any direction. Up 3, 1, 2, 3, right 2, and so on. Or again, I can go the other direction. Down 3, 1, 2, 3, left 2, down 3, left 2. Once you have those points, then you're going to get out your ruler. Let's just pull my ruler down. Your ruler or a straight edge of some kind, and you're going to connect your points. Probably easier for you to use your ruler on paper than I have on my smartboard. All right, and then you can connect your line. Ooh, that's a terrible line. Let's try that again. All right, that's a little better. So we'll just ignore that first line there. All right. Technical difficulties. Not quite exact, but we'll leave it for today. All right. So when we're drawing our graph, we'll get more into this tomorrow, but when we're drawing our graphs, you want to draw your grid through the entire graph and have arrows showing that it's extending. Now after that, then you can list other points, or you can use your math to get your other points. So if I had that we were going up 3 and right 2, so up 3, -3 plus 3 would be 0, and 0 plus 2 would be 2. So 2, 0, which if you notice is one of my points. Add another 3, add another 2, add another 3, add another 2, and so on. And I can check those points all the way up that they should be working. Again, I can do it the other way as well. I can subtract 3 and subtract 2. So -3 minus 3 would be -6, and 0 minus 2 would be -2, 6. And again, if I go -2, 1, 2, 3, 4, 5, 6 would be right there. All right, so that gives you a little taste of what's to come for the next lesson. See you in class, and make sure you ask questions if you have them. Have a good night.